Okay, so we left off in the first video kind of describing derating factors. Why do we have to do it? Now let's look at a few examples here. So in our first example, we have, let's say, number 8 conductors, THHN copper, in one raceway. So I left this table up here because we're going to have to go ahead and reference it for this example, right? So first thing we got to look at here, let's go ahead and bring up 31015B16 again, right? So remember, like I said, we have number 8 conductors here, THHN copper. So how many amps are they good for to start with? So let's go ahead and look in the THHN section, or refined THHN. We see it's in the 90-degree column. Again, I said we're using copper wire, so we're going to look here in this particular column. Number 8 wire in the left-hand side here. So we see where the two meet, and we find that it's good for 55 amps to begin with, right? So let's bring that over. Now, what do we have to do? Because we have more than 3 current carrying conductors, we know, okay, I have to derate it, but by how much? How do we do this? That's where 31015B3A comes in. So it tells us over here that if we have various numbers here, in our case we have 8, so we're in this section, we have 7 to 9 conductors, we're going to need to apply this derating value, this derating factor. It's actually a percentage. So we need to only take 70% of the original ampacity, right? So our 55 amps times 70%, according to our table, is only 38.5. So those number 8 conductors can maximum be used for 38.5 amps if I put 8 of them in one conduit. Right, so you see more conductors, they're not as good for as many amps, we've just derated, right? So not a whole lot to it as long as we know where that table's at. So let's look at the other side for the high ambient temperature. Let's say now we have number 4 gauge copper in an area that is 115 degrees ambient temperature. Okay, so we know we got a high temperature, we need to do some derating. So let's bring 31015B16 up once again. We know again we have number 4 copper. So we're going to look in the THHN copper section. We find it's this column once again. Number 4 over there on the left, we shoot it across and we find out that we're good for 95 amps to start with. So we bring that over. Now let's pull up that table 31015B2A once again that I referenced earlier. So this table, I think, can be a little confusing. So our ambient temperature is in Fahrenheit. So they're showing us Fahrenheit on the left over here, right? And it's in, again, different segments. So at 115, we would actually fall in this 114 through 122 category. Now I know that I'm using THHN, which I know is good for 90 degrees. So I'm going to come over here to the 90-degree column. And it's going to tell me I need to multiply my ampacity by 0.82. I don't know why they didn't stick with, it was a percentage on the other table. Now it's actually a decimal format, but regardless, we're going to do the same work here. So we're actually going to multiply our 95 amps by 0.82. We go ahead and do that, and we find that that number 4 wire is now only good for 77 amps because of the high ambient temperature. So that's kind of the first part of it all. Now, the part that I don't like about that is that's kind of reactive. That's assuming we already ran the wire and we say, oh, we might have a problem. Let's look at this. In reality, we might say, hey, I know we might have a problem. Maybe we need to run some bigger wires to account for this. So mathematically, how can we do that? I don't know if this is the right term for it, but I always call it the inverse reciprocal method. Sounds fancy. It's not really that fancy. So let's start with an example here. Let's say we have a 50 amp circuit. Okay, because usually you know the ampacity. You might not necessarily know what wire you need to run. That's what we need to figure out, what size wire. So we have a 50 amp circuit. What size wire can I run for that? Let's say I'm going to have 9 conductors in this conduit, and they all need to be good for 50 amps. So I have more than 3. So I come back, more than 3 current carrying conductors. So I come back to 31015B3A. I look for the section that contains 9 conductors. I find that here, and I know that it's 70%. I need to multiply by 70%. I'm going to do something different, and mathematically it'll sort of get us to the same place from a different direction. So I'm going to take that 70 and I'm actually going to divide it. I'm going to take 1 divided by 70%, or 1 divided by 0.7. So that's going to give me 1.429. So now I'm going to take that number, which I think you call maybe an inverse reciprocal. That's what I call it. Ask your math teacher. I'm not sure. Anyway, we're going to take that number. We're going to multiply that by our 50 amps. And we're going to get 71.45. So what that tells me is I actually need to select a conductor that's rated for 71.45. So you see, now I'm taking the guesswork out. I'm saying I need a conductor good for this. I'm only going to put this on it. But after I derate it by 70 in this case, it's only going to be worth 50 or more, right? So we kind of solve the same problem by coming at it from a different angle here. But so let's pull up 31015B16. And again, we said we were looking for 71.45. And let's say it's copper, THHN once again. I'm going to come in here. I know that 55 falls short, but 75, a number 6, is actually going to get the job done for us, right? So that's how you go about that process in selecting your wire. Again, maybe there's going to be an issue. We have more than 3 current carrying conductors in a high ambient temperature. What are we going to do? Here's the ampacity I need to achieve. Use that inverse reciprocal method. Find that new wire size that'll handle that load even after being derated, right? Inverse reciprocal. So we end up here in this case with a number 6, like I said. So again, that was, I don't think the math is very complicated, but it's a lot of references, a lot of things to check. So read through that text carefully. We'll rewatch this again if you need to. And please, if you need to see any more examples, don't hesitate to reach out. I'm happy to throw some more together for you guys.